wonderful platform, that is BYJU'S Exam Prep. And guys, today we are going to start the next subject, that is production technology. So in this subject, my dear, we are going to cover welding technology, which is a topic comes in GATE every year for 2 marks. So we will be starting the topic now. Okay, so guys, today's class is going to be related to the arc welding. You know that is the type of welding which is very important, from which every year one numerical is coming. So that's why, keeping that in mind, we are going to start with that. We will see principle as well as application and some questions. So please tell me, am I properly audible and visible to all of you or not? Then we will start the session. So guys, before we start, this is some introduction about me. Those who are watching me for the first time. So guys, I am having 10+ years of experience in this GATE and ESC field. And my dear, I have written many research and review papers, and these are my expertise. Okay, so today now we are talking about the production technology, guys. Manas, good evening. Midun, good evening, dear. So let us start the session, guys. So this is a small announcement about the scholarship test. You can get up to 90% scholarship by appearing in this test on 12th June, 11 AM on Sunday. So register now to get that benefit. Okay. Yes. Good evening, Madhu. Good evening, Shubham. So guys, before we start about the topic, we are going to start with the very basic introduction, because we didn't have a session over introduction of this subject. So guys, first of all, I would be telling you about what is the difference between production versus manufacturing. Actually, whenever you sit in any competitive exam or any interview or any viva, this is a very common question which is been asked by the interviewers or examiners from the student, that whether manufacturing and production are same thing or they are different, and if they are different, what is the difference between them. And my dear, as per my experience, as I have taught this subject many times, so whenever I ask this question to the student, then generally student answer in such a way that they say, sir, there are two things. One is production, one is manufacturing. And they say, sir, whenever we are talking about some process which is going to be with some you can say advanced machine, then it is said to be production, and which are done by manually, they say it manufacturing. Then I counter question them, have you seen the books on production technology? They say, yes, sir. Then I tell them, guys, there are some books with the name of manufacturing processes, like manufacturing processes by Amitabh Ghosh. There are some books which are by the name of production technology, like production technology by PC Sharma. If you see the contents of both, you will find all the topics: casting, welding, metal cutting, metal forming, computer integrated manufacturing, and you can say NC, CNC, metrology, inspection. All the content you will find more or less are same. So when you are finding out more or less same content, my dear, when we are finding out more or less same content in both, how you can say both are different? So I would like to say, my dear, when we are talking about production and manufacturing, with reference to mechanical engineering, both are same. So I will say, my dear, with reference to mechanical engineering, both are same. Both are same. Okay, my dear. So when we are talking about production and manufacturing with reference to mechanical engineering, they are same. Very good, Shubham. Very good. So they are same, my dear. But my dear, if you see production, that is somehow a general term. If you have seen some movies, when you are watching movies, at the end they are giving some names, and when they are going to credits, then my dear, you have seen produced by a word in the end of the movie. So my dear, you have seen produced by, they never use manufactured by. When you study biology, we say we are nothing but production of our parents. We are not manufactured by our parents. You have seen the chapter reproduction. It is not remanufactured. So my dear, it means we are using production in many other areas like arts. Let us say some painting is there. In the painting, they will be writing produced by. They will never write manufactured by. So the point is, produced by term is more used in many areas because it means production is some generalized word. So production is a generalized field which can be used in arts, commerce, many places. Okay, and out of this, a small part is manufacturing. And my dear, if you're talking about manufacturing, it is a subset of production. So that's why with reference to mechanical engineering, there is no difference between production and manufacturing. But yes, otherwise production is a general term which is used for other purposes also, but manufacturing is a small part of it. So guys, this is the difference between manufacturing and production. So my dear, now when the production, we have seen what is the manufacturing and production difference. Now we will see about the contents, the topics we are going to discuss in this subject. And my dear, when we are talking about the topics, the very first topic we are going to deal with the welding, and I would be telling you the marks as well as the important topic of that. So welding is coming generally for 2 marks, and they are normally asking a numerical from that, and the numericals are generally coming either from arc or resistance welding. So my dear, these are the 2 topics from which numericals are coming. From arc welding, they ask about VI characteristic, and from resistance welding, they are asking normally finding out efficiency types of things. Okay, so my dear, we are going to cover each and everything, don't worry about that. Okay, then my dear, second topic is metal casting. It is coming from 2 to 3 marks, for 2 to 3 marks, and in this you will get 1 numerical and 1 theory question. So my dear, numerical questions are generally coming from either gating system design, or they are asking about the riser design. Okay, sometimes they are also asking from the properties like permeability test. Okay, so these are the topics from where numericals are being asked. Theory question is coming from non-traditional casting methods like slush casting, okay, like centrifugal casting के अलावा investment casting. Those are the topic from where theory questions are coming. Casting defects sometimes maybe. Okay guys, next topic is metal forming. So guys, don't worry, we are going to study welding. In this series, we are going to prepare welding, and I will be teaching you complete welding. Means we are going to secure 2 marks in this 5 to 6 days. Okay guys. So I want to ask you first of all whether you are comfortable with this timing, or shall we change the time to 6 p.m. like previously we were having the sessions at 6 p.m. So that's why I was asking. So when we are talking about the metal forming, my dear, when we are talking about metal forming, you will be having around 4 marks. As you know, metal forming, we are going to study 2 topics. One is bulk metal forming, and from bulk metal forming you will be getting 1 numerical. Okay, then my dear, you are going to have sheet metal operation, and sheet metal operation you will be having 1 question. So sheet metal operation. So my dear, these 2 topics you will be having 2 questions. Bulk metal forming will consist of rolling, forging, extrusion, wire drawing. Sheet metal operation will be having punching, blanking, deep drawing. Okay, many operations are there. And my dear, then the next topic is metal cutting. It is the most important. The weightage is around 5 marks. Here majorly, my dear, they will be asking about single point cutting, tool geometry, merchant force circle, sometime non-conventional machining like ECM, EDM numericals will be there. So here also majorly numericals are coming, but you can expect 1 question from theory as well. So 2 to 3 questions from numericals will be there. So this is the highest weightage topic from mechanical engineering in production technology. Then my dear, metrology and inspection, here 1 numerical you can expect from limits, fits and tolerance, or you can have numerical from gauge design also. Hello Teju, how are you? So my dear, next topic is material science. The weightage is very less for gate, 0 to 1 marks, but sometimes this subject have surprised also when it was asked for 3 to 4 marks. But generally you can say 0 to 1 marks, and that question will be either from phase diagram or it will be from crystal imperfections. Okay, generally it is the scene. Okay, next is SIM, that is computer integrated manufacturing. From here we can expect theory question also, as additive manufacturing is added, but the weightage is again 1 mark. So my dear, entire subject you can expect from 13 to 17 marks. Every year it is coming within this range, so that I can guarantee this will be the weightage, 13 to 17 marks. Surya, 8:30 time will be there after 1 week, don't worry. Okay, so for this week on YouTube we will complete welding. So those who are interested to see the welding operation. I will be teaching it completely, guys, and I can guarantee you 2 marks for sure. Okay, so let us see about other things. So my dear, first of all, before we start welding, what is welding actually and what are the principle and all the things, I am showing you what you have seen in the colleges. When you went to the college, good evening Nagaraju, good evening. Yes, so my dear, when you went to the college in the first year, for the first year you must have seen there were 4 to 5 labs where you went for 2 weekends or 2 weeks you would be having. So 2 to 3 weeks are generally allotted for one lab. Hello Achintya. So my dear, when you went to the lab of welding, there will be a lab named welding foundry, है ना? There will be a carpentry lab. So likewise machining lab. So you would be having 5 labs. In those 5 labs, we get generally 2 to 3 classes or 2 to 3 periods of lab in every, you can say, in every lab 2 to 3 will be there for one semester. So when you went to these labs, my dear, when you went to welding lab, only one type of welding generally is shown to the student, that is arc welding. What they do is, they are going to take 2 work pieces, and whenever they are going to take these 2 plates, they want to join these 2 plates, they will be having an electrode holder and an electrode, and with the help of that you can see you will be joining these 2 materials. So this is the general thing about welding. We are going to see it in a great detail. Okay, so this I am showing what you know till now, if I am considering that you have completed your first year of engineering. Okay, after that, what are the things I am going to teach you? I will be assuming you don't know anything about welding. Good evening Rishi bhai. Yes, good evening. So let us start, guys. So my dear, before we start the first topic about welding, first of all we must define welding. What is welding actually? So if I ask you welding, everybody would be knowing this is a process of joining. So this is a process of joining. Yes, it's correct. So my dear, welding is defined as a process of joining 2 materials or 2 work pieces or 2 components with or without the help of heat, with or without the help of pressure, or both, with or without the help of filler material. What do you mean by that? You will be having 2 plates, 2 components. You will be joining them either with the help of heat or with the help of pressure, or both heat and pressure, and you would also be using some filler material to fill the gap between them, or you may not be using the filler material. So this is the general definition I have used for welding process. Now the real story is going to start, my dear. So when you are talking about welding, you have just seen that in the previous slide, if you see, you have just seen that how the welding is going to take place. If I consider this as workpiece 1, this as workpiece 2, so you have joined it, and if I show you this view of welding, then my dear, this view will show you some kind of this kind of figure. So this was plate 1, this was plate 2. Obviously this will be along the length which we are not showing. Okay, so I am showing you just one view with which you can see the cross section. I am once again telling you which view you are looking at. We are looking at this view. Okay, so we are looking at this view, okay. So when you are looking at this view, my dear, you just feel this is said to be weld bead geometry. When, my dear, we are talking that this is weld bead geometry, Shalom, this is going to be either on Thursday or on Saturday or Sunday. Okay, so tomorrow I will be telling you the right, the correct timing for that session, where we will discuss about the important topics of mechanical. Okay, so either on Thursday or Saturday or Sunday, out of these 3 days it is there. So tomorrow I will be telling you the confirmed date. Okay, so my dear, now we are talking about this. So this is 1 and this is 2. So my dear, this is said to be weld bead geometry. When we are talking about weld bead geometry, my dear, actually in this there are 3 parts available. In this weld bead geometry, my dear, this hatched part, this is said to be weld bead. This is said to be weld bead. And my dear, the very near region of this weld bead is said to be heat affected zone, and far away region of this welding, this is said to be unaffected zone. And my dear, if you see this weld bead, I would like to say, if I take a tangent here, you can see some angle is made. That angle is said to be, this angle is said to be, what is the name of this angle? The angle of obliquity. And my dear, if you see this angle is depending on this part. I would like to say this reinforcement, whatever you are seeing, this reinforcement have two parts actually. One part is within the plate, other part is above the plate. The part which is above the plate, this is given the name of reinforcement. The part which is below the plate or inside the plate is given the name of penetration. So this weld bead consists of reinforcement and penetration. So first of all, my dear, if you see these three parts, how these three parts are divided. My dear, if you see the previous case, you can see there is some part in which welding is going to happen. You can see there is some part in which welding is going to happen. Don't worry, I am showing you again. So there is some part in which welding is going to happen. So my dear, in this part, whenever you are going to see that electrode is like, let us say these are two plates, and my dear, that electrode is going to perform the welding like this. The electrode is going to perform welding like this. So my dear, obviously you can see this electrode is going to melt out and the molten metal is going inside. So my dear, if you see this electrode properly, this electrode is a wire like this. It would be a wire like this, and on this wire some coating is present. If my dear, you have seen the Deepavali festivals, then in Deepavali festival you are using one diya silai kind of thing. So similar to that, on a wire we are having some flux coating. And my dear, when you are having this flux coating is made up of different material, and this electrode wire is made up of workpiece material. So what I want to say that when both will be melting, they will be providing you some alloy content, because whenever we are going to join two metals, it is not going to remain the pure metal. They will become some kind of alloy. Very good, Teju. So they will become some kind of alloy. And everybody in this class would be knowing that alloys are said to be more stronger than that of the pure metal. This is partial truth. I would be clearing that thing in the time of material science when we will discuss, but for the timing let us go with your knowledge only. According to your knowledge, you would be saying that sir, alloy are stronger than the parent material. So if we are considering alloys to be stronger than the parent material, my dear, then obviously you can see this weld bead part is made up of that alloy content which is given by the flux plus wire, means electrode. So my dear, when electrode is providing that part is consisting of alloy. Because of that, my dear, this weld bead part is said to be the strongest part. This is said to be the strongest part. Okay. So my dear, when we are talking about this weld bead geometry, actually there are three things. One is weld bead, other is heat affected zone, and third one is unaffected zone. So I am showing you all the three parts. What are the three parts? One is weld bead, and we have seen that weld bead is found to be the strongest part. So can you tell me why weld bead is the strongest part? We have just discussed why this is said to be the strongest part in the weld bead geometry. Can anybody tell me that why this weld bead is said to be the strongest part? We have just discussed. Why? Because if you are getting this, you must be able to answer this, because from this already one question in GATE and engineering services have been asked that the strongest part is weld bead, but why? What is the reason? What you will say, guys? Anybody? I am waiting for your answer. Yes, because we are saying that alloy content are stronger than the pure metal. My dear, second part is heat affected zone. Now let us see what is heat affected zone. So my dear, when you are going to see the previous case, when you have seen that welding is going to take place. So here welding is going to take place with the help of heat, my dear. The welding is going to take place here with the help of heat. And my dear, if the welding is going to take place with the heat, the nearby region is going to be affected because of that heat. And as the nearby region is going to affected because of that heat, that is said to be heat affected zone. Now you must be understanding, sir, why it is affecting. So my dear, in material science, you must have seen there are some heat treatment processes. So heat treatment processes are done to improve the properties of a material. What we do in that, we heat some material, Then when it reaches to some temperature, we hold that body at that temperature, and my dear, then we start cooling it. So when we are going to heat there, it is already mentioned that up to which temperature we will go. When we are talking about holding, it is mentioned for how much time we are going to hold it. When we are going to cool it to room temperature, it is mentioned that with which cooling rate we are going to do. It means in heat treatment process, everything is defined. In controlled heat treatment, everything is already defined. What temperature, what timing, what cooling rate. But my dear, when the things are done in controlled way, they are going to benefit us. Like you take alcohol in terms of medicines also when you have cold and cough. But the same alcohol is going to harm you if you are going beyond limits, if you are going in uncontrolled manner. So my dear, the same thing I want to say, that in heat treatment processes, we are going to heat, cool, and third thing is the cooling, you can say holding for some time, that we are going to do in controlled manner. We are knowing up to which temperature we need to go for which material, for how much time we are going to hold. So everything is known to us. Very good, Surya. Yes. Aram, right now online classes are going on, but soon maybe offline classes would be coming, but right now we are online only. Okay, so okay, let's move to the topic. So my dear, as I was saying, that when we are talking about this heat treatment, in this nearby region to the welding area, if you talk about this region, the same thing is happening in uncontrolled manner. Because when you are going to have electrode between, like there are two plates and you are going to weld them, and you are going to have this electrode like this. So my dear, when you are going to have this, obviously heat is going to be there. And when you are going to heat, my dear, sometime you, for the proper welding purpose, we may be holding or we may be going with some slow or high speed. So my dear, because of that, heating is going to happen, and once the welding is going to happen, because of atmospheric air, the cooling will also happen. But my dear, here when we are going for welding, our main target is welding. Our main target is not about the nearby region, that we will think that up to which temperature they will go, up to which time they will be getting hold, and by which cooling rate they will be getting cooled. So these things are not known to us. So means I want to say that we are concentrated on this welding. We are not concentrating about this nearby region. So whatever the heat treatments are going on, they are going on in uncontrolled manner. And when heat treatments are going on in uncontrolled manner, then my dear, we will be saying that they are going to harm. And because of that, this region is given the name of heat affected zone. So when the same thing will be done in controlled manner in heat treatment, it will be giving advantage to us. So here it is going to give us the disadvantage. So the point is, that is why heat affected zone is found to be the weakest part. Okay guys, and when we are talking about the third part, that is the part which is far away from the welding area, that is not much affected by the heat of welding. So my dear, this is how we are going to, yes, very good, Teju. Residual stresses are generated sometime, and obviously for that, what we are going to do, we will see on the later on. But right now we are talking about the principles of welding. Okay, yes. So my dear, if we are talking about these three areas, weld bead is the strongest area, heat affected zone is the weakest area. If somebody asks you why it is weakest, you will call it as because of uncontrolled heat treatment. Because of uncontrolled heat treatment. So my dear, uncontrolled heat treatment is the reason for that. So my dear, that is why heat affected zone is the weakest one. And my dear, now we are talking about the third, unaffected zone. It lies in between. So my dear, you must be knowing that weld bead is strongest, unaffected zone, and weakest is heat affected zone. Even sometimes they are asking that we can reduce the heat affected zone by what? By increasing the speed of welding. If the welding speed will be more, less region would be affected because of the heat of welding, and we will call heat affected zone is going to be lesser. Thanks Shubham for your wonderful words. So this was, my dear, what we have discussed about the weld bead geometry. Now my dear, we are going to go more inside of this part. You can see, my dear, this red portion which is inside the plate is given the name of penetration, and my dear, the yellow portion which is outside is given the name of reinforcement. So my dear, when we are talking about this penetration and reinforcement, you must have seen the first slide where I am showing you the welding procedure, and you can feel it. After the welding procedure, you can see after the welding procedure some part of the reinforcement is going to be removed, because that becomes in the form of slag. You can see we are going to remove it. So my dear, I want to say that penetration part is going to be the more important part when we say this, and that is why a term is defined as dilution. So my dear, dilution is defined as area of penetration divided by area of penetration plus area of reinforcement. And sometimes they are asking about percentage dilution. We will be going to multiply it with the 100. So my dear, this is how we are going to define dilution in the welding process. My dear, right now I am just defining it. In the later stages of welding topic, I am going to derive the expressions for various cases. And my dear, from dilution till now there is no question in GATE. You can expect in 23 or 24 some question may be coming. So for that I am going to teach you all the things. If you are just in the learning phase, you are starting the preparation, or you have not seen even production, you can rely on me for this topic, because in next 6 days we are going to complete the welding chapter. Okay, I will be teaching you welding from each and every point of view. After that you can go for all the previous year's GATE problems from mechanical as well as PI paper. So this is my guarantee. Like in this time we are doing in that way only. We are taking any one topic and we are trying to complete it. Okay, so that is my guarantee. Yes, Divyansh Kohli, good evening dear, how are you? So my dear, this was something about dilution, and now we are going to start the very first type of arc welding, and the name is shielded metal arc welding, and it is also said to be sometime manual metal arc welding. So my dear, when we are talking about this, I will be teaching you complete each and everything about this. So what is the principle? Let us see that. So my dear, we have just seen, you have just seen this video I was showing you. So my dear, actually what is going on? We are going to have, let us say, these are two workpieces. We are going to weld them. This is your electrode. So my dear, when this electrode is, first of all we are talking about principle, then we will talk about the setup detail. So my dear, this is electrode. So my dear, when you can see electrode is going towards the workpiece, you can see there is some gap between electrode and workpiece. You know, whenever we are having workpiece and electrode, they are connected with some kind of power source. This power source can be AC, can be DC. We will also discuss when we will be using AC, when we will be using DC. Okay, sir, we put electrode incline while welding, or Madhuvamshi, that we will talk at the time of gas welding, but you have asked, I will be telling you. During starting of welding, we will keep it straight. After that we will keep the angle in between, and at the end of welding we will make it parallel, or you can say 0 degree. Okay, so at the starting 90 degree for concentration of energy, in between it is varying. Okay, in between it is lying between 0 to 90. So in more detail we will talk about this after gas welding. Okay, so for the timing, let us talk about arc welding. So my dear, when you are going to have this electrode and workpiece, you know, in between some air gap will be there. And my dear, when we are talking about air gap, more will be the gap, more will be the resistance. Because my dear, when this power source is there, you can see circuit is not complete. This is going to be workpiece, and let us say this is going to be your electrode. So my dear, there is some gap between them. Okay, there is some gap between them, and more the gap will be, more will be the resistance given by the air. Okay, so my dear, when we are talking about this, if by chance when you have tried this type of welding in your college, if by chance your electrode is going to just touch this workpiece, you have seen welding was not going to happen, nothing was happening, and you must have seen it was going to stick that, and at that time my dear, your circuit was completed, there was no welding going to happen, current was just circulating like that. So because of that my dear, there was no welding operation at that time, it was going to stick that. And my dear, if you have seen it is far away, then also there is no welding happening. So welding start happening when the gap between air and gap between electrode and workpiece would be reaching to some critical value. What is the reason behind that? Because my dear, you must be providing some potential difference about this, either minus plus or plus minus. So here let us assume workpiece to be positive, electrode to be negative. So my dear, when you are providing that kind of potential difference, that potential difference will not be capable of of passing the electron from the air if the gap between them will be more, and for more gap, my dear, resistance will be more. So when, my dear, you will be taking electrode towards the workpiece, there will be an instant come when the gap between electrode and workpiece will be reaching to that critical value, when that will be capable of ionizing the air between the gap. And when it will be capable of ionizing the air between the gap, my dear, it will ionize the air. And my dear, when air will be ionized means what? The gap, I am saying this is going to be workpiece means positive means anode, this is going to be negative means cathode. So my dear, between this air gap, air will be ionized, means it will be converting in the form of positive ions and negative electrons. It will become positive ions and negative electrons. So my dear, what will happen then? As I said, when the electrode will be going towards workpiece and the gap will reach to that critical value, at that time air will get ionized, and my dear, because of that now electron would be easily passing, and because of that some spark would be generated, and because of spark, my dear, the electrode, you can see this electrode is made up of one wire and other flux material. And my dear, we intentionally keep the melting point temperature of flux to be more than the electrode. So because of that, when the spark is going to be generated between the arc gap, by taking energy from that, electrode wire is going to melt first. So first electrode wire is going to melt, and after that the flux will be melting. And the mixture of electrode material, wire material and flux material will be going inside the groove and weld will be produced. So my dear, why it is said to be arc welding? Because the heat required for the welding process is taken from the electric arc. So that is why the name of the welding is arc welding. What is the principle of arc welding? That when the gap between electrode wire and workpiece is coming to the critical value, then my dear, air gets ionized, spark gets produced. By taking energy from that, electrode wire gets melt first, then flux get melt, and the combination is going to enter inside the groove and weld will gets produced. This is the principle of arc welding. And I would like to show you more intense things. I have made this diagram as wrong. Actually, and intentionally I have made it wrong. Actually, when we are talking about the electrode, as I am saying, electrode wire is going to melt first. So all the good books would be showing this diagram in this way, because wire is melting first, and my dear, after that the flux is melting. And the reason behind that, when wire will be melting first, it will be creating a converging spark, which is going to help to concentrate the energy at one place where we want welding to happen. If on the other hand, you will be making the flux to be melting first, or electrode wire to be melting in the last, then this kind of diagram would be there. And in that case, there are chances of divergence of spark and welding will not happen. So my dear, that is why we are making the combination in such a way that electrode wire must melt first. Okay, so that is the concept I wanted to give you. So that's why by mistake, it is not by mistake, I am making the diagram wrong for all the welding process. I have made it wrong, then I am correcting it by giving you the reason for explanation. Why? Because if I will making right diagram, then you may not be learning what is the mistake in that. Okay, what kind of mistake you can see in the books. So that's why I am telling you that this diagram is going to be the correct one, and that is how we are going to get a help in converging of the spark. Hope you are getting something new if even you have studied welding anywhere else. So my dear, that is what we are going to talk about. So my dear, that we have seen. Now let us go to this region more intensely. Let us go to this region more intensely, that what is going to happen there. So my dear, I am teaching you in a great detail. This is something about welding setup. You can say these are the cables going on. This is for earthing purpose to complete the circuit. This is going to the electrode holder. Electrode holder is having electrode, and there is the arc produced. Okay, so my dear, it can be AC or DC, depend on the requirement. This animation I have already shown to you. So my dear, now I am telling you about very important concept. So my dear, we are having, let us say the electrode is shown as cathode, because we have given this electrode as cathode, and we will be having this workpiece as anode, because we have given it as positive. So my dear, I already told you when the air is going to be ionized, then my dear, in between gap, that air will be converted into ions and electrons. So my dear, it will be converted into positive ions and electrons, positive ions and electron, positive ions and electron, positive ions and electron, positive ions and electron, positive ions and electron. Now my dear, negatively charged electron will be attracted by anode and positively charged ion will be attracted by cathode. So my dear, in the ionized air, electrons will start moving towards anode and positively charged ion will start moving towards cathode. And when they will be moving, that is happening because of the potential difference. So here potential difference is playing an important role. That is why this process is said to be high voltage low current process. High voltage and low current process. High voltage and low current process. Okay, this is said to be high voltage because with respect to other welding processes, its voltage is low, and it is said to be high. It is said to be low current because with respect to other processes, its current is going to be low. So we are comparing it with others. We are not comparing voltage with current. Actually, voltage will be in the range of 40 to 80 volt. Current will be in the range of, let us say, 400 to 1200 ampere. So you will say, sir, current is more. No, if you compare with resistance welding, their voltage will be 12 volt, current will be more than 10,000 ampere. So we are comparing its voltage with others' voltage, its current with others' current. So in that way, it is high voltage, low current process. Because of that voltage only, the air is getting ionized. So my dear, because of that ionization, electron will move to anode, ions will move to cathode. When these positively charged ions will be colliding with the cathode, they will be providing some kinetic energy because they are moving and they are having some kinetic energy, and that kinetic energy is converted into heat energy when they are going to collide with cathode, and that heat energy is given to the cathode. Who is cathode? Electrode. So because of that, electrode wire will be getting melting. And my dear, at the same time, anode is getting all the electrons. Electron is also having kinetic energy, half mv square, that will be given to the anode. Anode means workpiece. And it have been seen that if we are going to see electron versus ions, they are having energies in the ratio of 2:1. So if 100 joule of energy is going to be produced, 67 will be going to the anode and 33 will be going to the cathode. And that is, we are saying this positive, negative. Some of you may be thinking, sir, can we use opposite also? Yes, that will depend on our requirement. If the working plates are thicker, we need more heat here, then we will go for positive anode, negative cathode, positive workpiece, negative electrode. Okay, and that is ideal condition. We will talk about other conditions in the other welding process tomorrow or day after tomorrow. So for that timing, this is what is going to happen. And my dear, when electrons are going towards anode and ions are going towards cathode, in between they are colliding also. And my dear, when they are going to collide, my dear, for that purpose, when they are colliding, because of that also some heat is generated in between the gap, and that heat is creating a very high temperature of around 6000 degrees Celsius between this gap. So this gap may reach to a temperature of 6000 degrees Celsius, and at that high temperature, my dear, there are some ultraviolet rays are going to be produced. And for the safety of those rays, my dear, safety glasses are required, and that is why it is always advised to use the safety glasses during the arc welding, because some UV rays are going to be produced. And my dear, if you will try to watch this welding without the glasses, I can assure you, you will be having sleeping problems for at least 2 to 3 days. You will feel some problems in your eyes for 2 to 3 days at least. Okay, you can try this, but I will not suggest you to try this. That will definitely be harming your sleep for 2 to 3 days, and you will feel some problems, some kind of pain in the eyes for 2 to 3 days. So never go with that. Always use the glasses. Without glasses, do not watch such type of welding process. So my dear, this we have seen some intense. Now my dear, you must ask me one thing, sir, that why we are using this flux material? There should be some function of flux, otherwise why we are using it? Why not only electrode wire we are using? So my dear, everything is having some reason. Don't worry, we will be telling about all the things one by one. So when we are talking about the flux coating, you can see that this is shown as core wire. This core wire is made up of generally same material as that of this workpiece is. So workpiece and wire are of same material. But when we are talking about this flux coating, we are having this flux coating separately. So this flux coating is having many functions. So let us talk about those functions one by one. The very first function of that is alloy content. You already have seen, sir, the weld bead part is the strongest part. So why, guys, do like and share the session. यार इतने अच्छे से आपको explain करके पढ़ा रहा हूँ, at least like तो कर दो. Like करोगे, then only I would like to know that whether you want such sessions or not. Okay, so don't be so confused. Okay, so just like the session, share the session, and subscribe the channel if you have not till now. So my dear, when we are talking about alloy content, you already know there are three parts. One is weld bead, other is heat affected zone, and third one is unaffected zone. And out of three, you know which one is the strongest one? My dear, strongest one is going to be the weld bead. Why it was strongest? Because of alloy content. Who is going to provide alloy content? Because wire is having the same material as that of workpiece. So my dear, flux will be providing you the alloy content. So my dear, this is the first function of the flux coating. It will provide us the alloy content. The second is, my dear, it is protecting from atmospheric gases. Like someone is writing, yes, Kevin is writing, in advanced process why we should replace inert gas. Dear, that we will talk, don't worry. I am teaching you complete welding. Today I am just telling you the principle of arc welding. So we will be coming to all those points in the upcoming classes. So I don't want to spoil other classes by telling all these things here. So just wait and watch. Okay. So my dear, when we are saying that protects from atmospheric gases, actually my dear, what is going to happen, I am going to tell you. When we are going to have this flux coating, you know that flux plus electrode wire material is going to melt out and it is going inside the groove. So my dear, in your flux, we are adding some components which are lighter. We are adding some components which are lighter than the parent metal. Means if welding is going on with some particular material, then my dear, lighter than that we are adding in the flux. So when we are adding some materials which are lighter than the molten metal, then what will happen? My dear, lighter material will be coming up. Like if you have this as molten pool, in which all the melted portion is coming. It is nothing but the combination of metal wire as well as the flux material. So my dear, what will happen? The flux material which is lighter will try to go up. This flux material which is lighter will try to go up. And it will be making a protective layer outside. And my dear, this flux material will not allow the air to come in contact with the molten metal. So this connection will not be possible because this lighter flux will be coming in between. But why we want this kind of thing? Why we want to protect the metal from the atmosphere? Actually, my dear, like everybody have some bad habits. Everybody have some bad habits. Like I am going to tell you, like I may be having a habit of waking up late. You may be having some other bad habit of eating more, eating less, eating at different times. Many things are there. So like our metals are having a bad habit. When they see oxygen nearby, they cannot control themselves. When they see oxygen nearby, they cannot control themselves if they are in heated state. If they are in heated state, and here they are not only in heated state, they are in melting state. So my dear, they are having a huge heat, and because of that heat, they cannot control themselves. So my dear, when they cannot control themselves, they just react with oxygen present in atmosphere. And when they are going to make oxides by reacting with oxygens, they will be producing metal oxides, M4 metal. And my dear, these metal oxides are very, very hard and brittle in nature. they are ceramics actually. So when they are very hard and brittle, my dear, then you know that if weld bead would be consisting brittle thing, you know the behavior of brittle materials like glass. If glass is there in your hand and by chance it went out of control and it go down, it will be broken up. So if in welding brittle component will be there, my dear, it will be broken up very fast. But we don't want that. Yes, Madhu, Vamshi, Midhun, Teju, very good. So we don't want that because welding joints are said to be the strongest joint in nature. If they will consist of metal oxide, they are going to be very weak. Why weak? Because of their brittleness. They are not weak in terms of strength, they are weak in terms of brittleness. Because if their brittleness will be there, they will be just broken up if some force will be coming. So my dear, we never want this kind of characteristic with the welding part. So that is why, my dear, we are not allowing our molten metal to be in contact with such air, so that we want it to not see the oxygen. If they will be not having direct contact with the oxygen, they will not be getting converted into metal oxides. So my dear, that is the second function of this flux coating. This function will always remain there. If flux would not be there, we would be using inert gases like Kevin was saying us. Okay. The third thing is direction to flame. That we have already discussed how it is giving direction to flame. We are keeping the melting point temperature of flux to be more than the molten metal. So molten metal melt out first. So we will be having that kind of thing. I have already shown you, I feel so. We have talked about this. Yes, here we have talked about this. So my dear, these are the three things we have seen, the advantages of flux coating, and that is why we are using the flux coating. So guys, please tell me till this point everybody is clear or not. So you must be knowing that this lighter flux is coming up and making a layer. After solidification, this layer is said to be slag. After solidification, this layer is said to be slag. Okay? Yes. So guys, let us move first. Now my dear, we have seen the advantage of lighter flux. Now I am telling you the disadvantage of lighter flux. What is going to happen? So my dear, if you have this molten weld pool, so my dear, you know that we are having some molten metal in this, like this. And my dear, you know that some flux is also there. So that flux will try to go up and is trying to make the layer which is going to save the molten metal from atmospheric gases. And you know, my dear, this must go up only in the stage when this entire thing is liquid. But you know, this will not remain always liquid because heat is continuously going out from metal to atmosphere. So it is solidifying also. And my dear, let us say if you are not providing current setting proper, because when you are using the current for the welding purpose, you are getting some heat generation of I square RT. And if you are not providing the proper current, my dear, let us say you are providing less current setting. If you will be providing less current setting, my dear, then the solidification of this weld pool will happen soon. The solidification of this weld pool will happen soon. And if solidification happen without our flux is going to reach at the top, then my dear, that flux is going to solidify in between the weld pool only. It will not be able to go to the top of that. It will not be able to reach at the top and saving the molten weld pool from the atmospheric gases. And my dear, it will be getting in between this molten weld pool. And if it will be solidified in between, you know, after solidification, we are saying it to be slag. So I will say slag remained inside, and this defect is given the name of slag inclusion. This defect is given the name of slag inclusion. In other words, flux बीच में फंस जाना, slag बीच में solidify हो जाना, flux बीच में solidify हो जाना. So solidification of flux in between the molten weld pool, and it is not coming to the up because of the lower current setting. This is said to be slag inclusion, and my dear, this is nothing but a welding defect. So my dear, I don't have a habit to teach the defect at the end. I will be teaching all the defects in between where they will be coming, because now the reason is very easily explained to you. Otherwise it is going to be very difficult to understand that why this defect is coming. So when you are studying the welding, you will be knowing that why slag inclusion is coming. So when you know the reason with this, you will never forget that defect. Otherwise, it is difficult task to revise or remember all these kind of welding defects as a separate. Okay. So my dear, this is slag inclusion. Now my dear, what are the movements which are happening for welding process? You know that my dear, these are the workpieces. This is electrode. So during welding, one movement is going for this electrode towards the workpiece, other is going along the workpiece. So there are two movements, one is towards the workpiece, other is along the workpiece. So my dear, when we are talking about these two types of movement, the first movement is towards the workpiece, the second movement is along the workpiece. And when we are talking about these two movements, my dear, when we are talking about these two movements, the towards the workpiece and along the workpiece, I feel everybody would be aware that this movement is going to be more important. Why more important? Because everybody know that the gap between electrode and wire will decide the air resistance, and if this air resistance will be more, there is no welding is going to happen. And my dear, more the gap, more the air, more potential difference will be required. So if we are going to make a curve between voltage and the gap, the curve is coming like this, and this is defined as V is equals to A plus BL. So my dear, the point is, if more gap will be there between them, more voltage will be required. Okay, that is what this curve is going to say. And you already know, if voltage requirement is going to be more from this, if my dear, you are going to have this workpiece and electrode like this, if the gap between them is going to vary, then my dear, this voltage requirement is also going to vary. And you know my dear, if voltage is going to vary, current is also going to vary. Current is also going to vary. And my dear, if that kind of variations will happen, the current setting is going to be disturbed, then my dear, you can understood that we would be having the defects like slag inclusion. So my dear, because of that, these two movements when we are going to see, first movement is going to be more important, second movement is going to be less important. Shubham, that they are two techniques. I am not telling about techniques. I am talking about movements of component during the welding process. So techniques are different, that we will see after gas welding. So my dear, these are two movements, and this movement is going to be more important. So my dear, if we want to make our welding defect proof, then obviously we need to have control over this movement first. So my dear, based on the movement of these two kinds, one is towards the workpiece, other is along the workpiece. This entire arc welding process is defined or classified in three categories. The very first type is automatic welding. My dear, if both the movements, this one and that one, towards the workpiece, along the workpiece, if both the movements are done by machines, then this type of welding is said to be automatic welding. If both the movements are done by machine, it is said to be automatic welding. My dear, you know the most important movement is the first one. So if we do the first movement by machine and second movement manually, because second movement is not going to create such kind of defect, then it is said to be semi-automatic type of welding. And my dear, if both the movements are done manually, then this type of welding is said to be manual metal arc welding process. So my dear, when we are talking about automatic, there is no issue of slag inclusion. In semi-automatic also there is no problem. So problem can happen in manual metal arc welding. If someone says, sir, I am going to use manual metal arc welding only, so is there any way that we can reduce the defect with manual metal arc welding? Is there anything for that? Yes, my dear. For that, there is a special kind of transformer. My dear, there is a special kind of transformer which is said to be Drooper. So Drooper is a special type of transformer. It is also given the name of constant current transformer. Constant current transformer. So my dear, the problem with manual metal arc welding is, when you are going for manual metal arc welding, my dear, then there is a problem of this movement. That if the gap will be changing, the voltage will be changing, the current will be changing. And that current change is resulting into slag inclusion. So what this Drooper is going to give? Drooper is providing special kind of VI characteristic of this type. You might be thinking, sir, we have studied V is directly proportional to I in Ohm's law, but my dear, Ohm's law is not followed by every device. Ohm's law is followed by some devices which are said to be active. Those which are not following are said to be passive. Okay. And second thing, transformers are meant to give us some different characteristic. So those different characteristics are given by this Drooper, and Drooper is providing this type of VI characteristic. And if you try to see this VI characteristic, let us say because of change of length, voltage is going to change by this amount. Then my dear, you can say current will be changing by less amount. You can see here change of voltage is quite high and change of current is negligible. So my dear, in case of Drooper, for more change of voltages, the current changes are very, very less. So because of that, we can save our weldings from the defect like slag inclusion. So my dear, this is the idea about the Drooper. So they are also known as constant current transformer, and they are used with manual metal arc welding processes. But my dear, this was the theory we have seen for the arc welding principle and the first type of arc welding. Now my dear, I am going to give you the formula for the transformer which is used in semi-automatic type of welding, the VI characteristics, and my dear, from that numerical is coming. That numerical we are going to discuss tomorrow. So I am just giving you an idea today. We will start numerical tomorrow only, because this was the first class. So here we have discussed only some basic things. So my dear, when we are talking about the VI characteristic of semi-automatic type of welding. So for semi-automatic type of welding, my dear, they are giving this type of characteristics. This is between voltage and current. And my dear, in this curve, this is said to be the highest voltage, given the name of open circuit voltage. This is the highest current, given the name of short circuit current. So my dear, when we are talking about IS, it is said to be short circuit current. What is short circuit current? I already told you, during the welding process, whenever by chance, by mistake, your electron was in touch with the workpiece, at that time there was no welding happened, you know that. So that is the highest current which was passing through, and because circuit was closed, there was no potential difference. Okay, so my dear, that's why it is said to be shortest current. So this is the current for which voltage is 0. And my dear, similarly, you know, when you were taking electrode towards workpiece, welding started only for some critical gap. Before that, welding was not happening. So my dear, whenever we have this is symbol shown by the EMF. And my dear, when we are talking about EMF, you know that this is giving us the potential difference between 2 points like this. So when there are 2 points, there is no device between them, then whatever the potential difference is, that is said to be EMF, electromotive force, and the same is said to be open circuit voltage. And when you are going to apply some device here, then there are some internal losses, internal resistance, then my dear, voltage is given by V. So my dear, this EMF is nothing but open circuit voltage. This is the highest voltage for which current is 0. When you will put a device here, my dear, it will start, current will start following. So my dear, when the current is going to start following, then the potential difference between these two will be said to be the voltage. So this is the difference between EMF and voltage. EMF is nothing but open circuit voltage. And my dear, if this is open circuit voltage, there is a relation between V and O. It is given as V as that open circuit voltage is also denoted as V0. So I will be writing it as V0. It is also given as V0 minus I into internal resistance. And this internal resistance is given by open circuit voltage by short circuit current. So my dear, you are getting the equation as V is equals to V0 minus V0 by IS into I. This is said to be the VI characteristic of the transformer. And don't worry, I will be also showing you this with the mathematics. If you see this, if you want to write the equation of this, how you will write? You will write as V, you know na, Y by A, X by A, Y by B. Yes, the same way. V by V0 plus I by IS is equals to 1. If you write this straight line equation, with that also you can reach to this result. Tomorrow I will be showing you this conversion, and we will start some numerical practice on this topic. So be ready for tomorrow's session. Tomorrow's session will give you a clear picture how to solve the questions on this type of topic. And my dear, tomorrow we will see submerged arc welding, TIG MIG welding, and I will not be only teaching you like that. I will be telling you why we need the other type of arc welding when we were having this one. When I will teach you submerged arc welding, I will tell you what are the problems with that. Then why we are reaching to TIG MIG, why we are reaching to electro slag and electro gas, why we are reaching to plasma arc welding. So there is a reason why we moved to the second type of welding process when we were already having the one type. So all those things, my dear, we are going to see in a great detail. And my dear, I also want to ask you, like in this Sunday, we have seen previous year's questions of strength of material from mechanical branch. Now, my dear, because time was less and there was a session on app also, so because of that we stopped at that time. So this Sunday, do you want the same for civil engineering SOM and mechanical and civil engineering mechanics? Because half session we have completed 25 questions and there were total of 50 questions. So are you ready for this Sunday for rest 25 questions? And this will really give you an idea how your preparations are going on, okay? And if you will definitely like it, you must like it, otherwise that's depend on your mood. But if you will do that, I can assure you that one thing, that it is going to help you in your preparation. You must go for this type of sessions here. We will go for all the subject if you want, okay? So we will meet, don't worry, but tomorrow 8 PM once again we will meet for the question part of arc welding and for other types of arc welding. Tomorrow we will complete arc welding, then day after tomorrow resistance welding. Like that we will see all the types of welding. So goodbye guys for this session. I am sharing this PDF with you in the Telegram channel within 1 hour. So goodbye guys, signing off today. Goodbye.